Okay, now we continue with the chapter. The next topic that we have is called as photoelectric effect. Now, around 1903, Heinrich Hertz आपने नाम सुना होगा, was doing an experiment. ठीक है, he was doing an experiment where he was testing electromagnetic waves. So people, we have a metal here. Connected to, let's say, negative terminal of the battery. And we have another electrode over here. This is connected to the positive terminal of the battery. Okay. Now the electrode present over here is made up of conductive metal. Conductive metal means usually alkali or group 1 metals. As per syllabus, okay, we consider that this is either sodium, potassium or rubidium. However, you can still have, when Hertz was doing this experiment, he did it with not any particular metal in he was not testing this for any particular metal. I think he took zinc, but then they were later, the same experiment was done with different metals. It was done with nickel, it was done with gold, so on and so forth. But हमारे syllabus में हम बोलेंगे फिलहाल के लिए it is sodium, potassium and rubidium, or elements which have low ionization energy. What do you mean by ionization energy? Energy required to remove the most loosely held electron. Okay? And you'll eventually understand the reason why. Now, what he did is, light was incidented on the metal, and he observed that as soon as light was incident on the metal, electrons came out of the metal. Obviously they went from the negative terminal, got attracted towards positive terminal, and यहाँ पे there was something to check, to test that. You connect something and you can also test that yes, there is flow of electrons. I repeat, this was the experiment done. Wapas, in simple language, he has a metal on which when light was incidented. Now it's not that any light, if you could incident any light, that electrons came out of the metal surface. This light had to be of a particular frequency. Only when light of a particular frequency was incident on the metal did electrons come out of the metal. Okay? This was the experiment done. Hertz, however, couldn't really explain as to why is this happening. And not only that, later on many successive experiments were done, but no one could explain कि बाबा ऐसा हो क्यों रहा है, that if you incident light of a particular frequency, Then electrons come out. If you increase the frequency of the light, the kinetic energy was increasing, kinetic energy of the electrons. But all this couldn't be explained, and the problem was this couldn't be explained because they were still considering only the wave nature of light to explain this. But we know that light has dual nature. It shows wave-like properties, but it also shows particle-like nature. And what happened is, the year 1905, probably one of the you can say that it was an extraordinary year, 1905, because in 1905, Albert Einstein, he was 26-year-old, though not part of the syllabus, but थोड़ा बहुत पता होगा तो अच्छा है. अरे, but he was 26-year-old. He wrote 3 extraordinary papers that year. While he was working at a local patent office, because कोई यूनिवर्सिटी में जॉब नहीं मिला था as a professor. So he wrote 3 extraordinary papers. The first paper, आज उसके बारे में थोड़ा पढ़ेंगे. We are going to study very basic हमारे जो syllabus में है, which was photoelectric effect. The second paper he wrote was on special theory of relativity. The third paper he wrote was on Brownian motion or Brownian movement. Brownian movement, I don't know 10th standard तक आपने, it is something which proved that molecules exist in a simple language. And his paper of 1905, eventually in 1921 he got a Nobel Prize for this paper. And even almost after 105 years, there is still industry applications of photoelectric effect. Now what Einstein did is, Einstein took Max Planck's quantum theory. What did Planck say? Light is made up of photons, which are bundles of energy. Einstein said that what is happening over here is, let's say this is the surface of the metal. Remember people, these are alkali metals, or metals in general have a lot of free electrons. ठीक है? And conductive metal है. The reason they are, or they conduct, is because they have free electrons. So these are all electrons. Einstein said that whenever photon of a particular frequency is incidented on the metal, this is your photon. Remember, it should have a particular frequency. Excuse me. The moment the photon is incidented on the electron, what happens? The electron will absorb that photon. When it absorbs that photon, it gains and it comes out of the metal surface. So when a photon is incidented on an electron, the electron gains energy, comes out with the metal surface with some amount of kinetic energy. Any questions still here? So what Einstein did is, he gave something called as the photoelectric equation. Einstein told that the energy of the incident photon so we're talking about ye photon. The energy of this incidented photon is used for 2 purposes. The first purpose is to remove the electron from the surface of the metal. ठीक है? So photon आया, this is the electron, collide किया, the electron got excited. So to remove the electron from the metal surface, and is also used to give some kinetic energy to the electron. Did you will get that? So the energy of this photon has 2 purposes. First क्या है people? 2. remove the electron from the surface of the metal, and second, it has to also have some amount of kinetic energy. What is the formula for energy of the incident photon? Energy of the photon is h nu. Yes or no? To remove the electron from the metal surface is also called as the work function of the metal. And this work function of the metal is given by the symbol phi, phi. And the formula for work function is h nu naught. The formula is same. However, instead of frequency nu, what have I written the frequency as? Nu naught. Now, what's the difference between nu and nu naught? Nu naught is called as minimum threshold frequency. Remember, starting me what I said is, it's not that you can incident light and electrons will come out of the metal surface. You need to incident a particular light or light of a particular frequency. It is only when nu is greater than nu naught, if nu or the incident light frequency is greater than or equal to the threshold frequency, electrons come out of the metal surface. Did you get that? So I repeat, it is, and every particular metal used will have a different threshold frequency. So the frequency, let's say, which worked for potassium may not really work for sodium, or let's say the frequency which worked for sodium may not really work for nickel, things like that. So h nu, which is the energy of the photon, is equal to h nu naught, which is work function. Work function is nothing but the energy required to remove the electron from the metal surface and to impart some kinetic energy. What is the formula for kinetic energy? Half mv squared. This equation is known as Einstein's photoelectric equation. And this is extremely important. This confirmed one of the theories of particle nature of light. So wave nature of light, there is interference, there is diffraction to prove wave nature of light. But to confirm particle of nature of light, one of the experiments which confirms that is photoelectric effect. With me till here? Bolo re? Chalo. Now I can further modify the formula a bit. I can write nu as C over lambda. So hc by lambda is equal to hc by lambda naught plus half mv square. Just different ways of writing the same formula. Next, h nu minus h nu naught is equal to kinetic energy. What I just did is I took h nu naught to the left, so you can write the same formula as h nu minus h nu naught is kinetic energy. Did you get that? Now I want you to observe this equation. Nu minus nu naught is kinetic energy. I can take something common over here, h. So if h is common, what am I left with? Nu minus nu naught is, h is a constant. Which constant is h? Planck's constant. Nu is frequency. This tells me that the kinetic energy of the electron is directly proportional to frequency. अगर आपको electrons की kinetic energy increase करनी है, what will you increase? You will increase the frequency of the incident light. If you want to increase current, ये, or if you want to increase the number of electrons coming out, if you want to increase what is called as photoelectric current, in short, if you want to increase the number of electrons coming out, you will increase the intensity of light. I repeat, if you want to increase kinetic energy, you increase frequency. If you want to increase the number of electrons coming out, photoelectric current अगर आपको बढ़ाना है, then you will increase the intensity of the incident light. With me till here? I'll give all this theory maybe, but अभी भी समझ लो. So, if I want to plot this, on the x-axis I have frequency, and on y-axis I have kinetic energy. ठीक है, this is frequency और ये kinetic energy. What's the frequency here? 0. अब मैं light incident कर रहा हूँ on the metal. Will the electrons come out? Yes or no? Frequency 0 है, मतलब light ही नहीं incident हुआ है. Then I keep on increasing frequency. It was observed that till a particular point, the kinetic energy was 0. Why? Because the frequency had not reached. What frequency is this? Threshold frequency. So till the point the frequency doesn't become equal to, will electrons come out of the metal surface? No. Now when you further increase the frequency, what will happen to the kinetic energy of the electrons? They will keep on, the kinetic energy of the electrons will keep on. Did you understand the plot? Why is the plot, or why is kinetic energy till this point? Because the frequency of the incident light has to become equal to the threshold frequency. ये क्या plot किया हमने? We plotted kinetic energy versus frequency. But if I plot photoelectric current, photoelectric current versus frequency. First of all, is there any relation between photoelectric current and frequency? No. Current was related with intensity. Now tell me, will any electrons come out till nu naught? I repeat, will any electrons come out till nu naught? No. Why? Because the threshold frequency has to be equal to the frequency. What will happen at nu naught? Will electrons start coming out? Yes or no? Will there be any deflection in the ammeter? It will start showing current. Why? Because electrons have started to come out. But if I increase the frequency, will the current increase? No, it will not. And hence, the current graph looks like this. The graph is like this. Let's understand the graph again. till the frequency reaches threshold frequency, are electrons coming out? Nope. The moment the frequency becomes equal to threshold frequency, do electrons start coming out? Yes. The emitter was at 0, let's say it goes to 0.1, and hence you see that spike. However, if you keep on increasing the frequency, does current increase? No. But what increases? What increases? Kinetic energy. Will you get that? Experimentally, when we'll do this, तो ऐसे curve नहीं होता है. The curve will look like this. वो थोड़ा ऐसे दिखता है. It's not exactly like this. ठीक है? तो कहीं पे अगर ऐसे दिखा, it's so that it is incorrect. With me? But now I want to increase photoelectric current. So what will I do? I should increase the intensity. So let's say I use two different light. एक में मेरे को curve ऐसा मिला, एक में मेरे को ऐसा मिला. I have two different intensities. Let's say this is I1 and this is I2. Which one is greater? Which intensity of light was greater? I2 is greater than I1. Anyone will not get that? Bolo re. Now, I want to plot kinetic energy versus intensity of light. Say, I go from 0 to nu naught, but now at nu naught, instead of increasing frequency, I am increasing intensity. What will happen to kinetic energy? Will kinetic energy increase? Kinetic energy is independent of intensity. So what will happen here? Even if I increase the intensity, kinetic energy remains constant. But what about photoelectric current? If I increase the, we've reached nu naught. If I increase the intensity, what will happen to photoelectric current? It will increase. Anyone who did not get any of the plots? Sound में please add.
The second one, you use lights of two different intensities. So what
Just a
they
second.
increase the frequency?
Please write down. When a beam of light of suitable frequency, when a light beam of suitable frequency is allowed to fall, on the surface of metals, such as sodium, potassium, rubidium, cesium, sodium, potassium, rubidium, cesium. Electrons electrons are ejected from the surface of the metal. Electrons are ejected from the surface of the metal. This is known as photoelectric effect, or sorry, not or, and the electrons ejected are known as photoelectrons. Observations. Electrons are ejected as soon as the beam of light strikes the surface. Next point. For each metal, there is a characteristic minimum frequency. Known as threshold frequency. Only if the frequency of incident light is greater than the threshold frequency, the ejected electrons come out with some kinetic energy. Next point, preferably red pen. The kinetic energy of ejected photoelectrons. The kinetic energy of the ejected photoelectrons depends only on the frequency of the incident light. And is independent of the intensity. Next point, red pen. The photoelectric current the photoelectric current, bracket me you can write the number of electrons coming out of the metal surface. The photoelectric current, or the number of electrons coming out of the metal surface, depends on the intensity of the incident light. Depends on the intensity of the incident light and depends on the intensity of the incident light and is independent of the frequency. And the last point, the energy of the falling photon should be greater than or equal to the energy of the falling photon should be greater than or equal to the ionization energy of the metal. Ionization energy. Chalo. I want you to copy this, and after this what we're going to do is we're going to do a topic called as stopping potential. So the next topic that we have to do is called as stopping potential. Now let's say we are performing same photoelectric effect. We know that when light is incidented, electrons come out from the metal surface. Now we know that, let's say, electrons are coming out of the metal surface. But what we do here is we are projecting or directing the electrons to move towards a particular electrode. And what is the charge that we have applied on that electrode? Negative charge. So do you think electrons will get attracted towards that electrode, or will it be repelled? Okay, but see, the electrons are flowing with, or they travel with very high velocity. So let's say this is, the electrons are flowing from here, and this is the negative electrode, and they're traveling at very high velocity. What we're trying to do is, they're going at very high velocity. There is some amount of kinetic energy present in the electrons over here. What we're trying to is, we are trying to stop the electron. What do you mean by trying to stop the electron? Is so that yahan se eventually when the electron reaches, what will its kinetic energy become? 0. You can also do the opposite way, but what we're trying to find is called as the potential required to stop the electron. And the potential that you apply to stop the electron, at that potential what we have, we say, is the maximum energy which was required to stop the electron. This energy is called as its kinetic energy, Kmax. And this Kmax is given by the expression the charge on the particle into the potential applied. The charge on the particle here is E, and the potential that we've applied is V, or this potential over here is also called as the stopping potential. So V stop is called as and kinetic energy hence is also given by the expression charge, that is E into stopping potential. Did you will get that? Chalo. So please write down सबसे पहले stopping potential. Stopping potential. It is the opposing potential difference. It is the opposing potential difference bracket mein you can write the stopping potential difference which can just stop the fastest moving electron, which can stop the fastest moving electron, which can stop the fastest moving electron in photoelectric effect. In photoelectric effect. That is photoelectric current in the circuit becomes zero. Photoelectric current in the circuit becomes zero. Copy the expression and we stop here. Next class we will continue with only the numericals on photoelectric effect. I repeat, we will be doing only numericals of photoelectric effect.